Okay, my children, now we are going to discuss statistics. In this chapter, we are going to discuss the concepts of exercise 14.3. Okay, my children, in the previous class, we have discussed some points in this exercise. How to construct a histogram, how to construct bar graphs, and how to construct histogram for a given frequency distribution. I hope you have learnt well. I hope you have understood that concepts well. Haven't you, my dear children? Right. Now come to the remaining concepts in this exercise 14.3. Okay, my dear children, are you ready to listen the class? Right. In the previous class, we have discussed how to construct a histogram of a frequency distribution of class intervals with equal. Okay, my children. Earlier, this problem did not arise because the widths of all the rectangles are equal. Means the widths of the class intervals, size of the class intervals are equal. But sometimes in the frequency distribution, they will give the class intervals with unequal sizes. In this case, how to construct a histogram? Okay, my children, right. In this case, we need to make certain modifications in the lengths of the rectangles so that the areas are given again proportional to the frequencies. This is the main point. The areas of the rectangles are proportional to frequencies in a histogram. Based on this concept, we had to modify the lengths of the rectangles so that the areas are again proportional to the frequencies. Okay, my children, understood this point? Right. Then what are the steps to be followed to modify the lengths of the rectangles so that the areas are again proportional to frequencies? See these steps, my children. Select a class interval with the minimum class size. For the next example, we take an example. In that example, the minimum class size is 10. Okay, my dear children, we have to identify the class interval with the minimum class size. Okay, my dear children, first step this one. And the second step, the lengths of the rectangles are then modified to be proportionate to the class size 10. Okay, my dear children. For instance, when the class size is 20, suppose the class size is 20, the length of the rectangle is 7. That is a frequency of that particular class is 7. In that case, we have to modify. How to modify? Then the class size is 10. The length of the rectangle will be 7 by 20 into 10. Okay, my children, that is equal to 3.5. So this is the modified length of the rectangle. Understood this point, my children? Let us take an example to construct a histogram with unequal class intervals. Okay, my children, right. So, for instance, when the class size is 20, the length of the rectangle is 7. So, see here, this is the first class. Its length of the class interval is 20 and the frequency is 7. In that case, here we have prepared a new column, that is width of the class. The length of the class interval or size of the class interval is 20. What is the size of this class interval? 10. The size of this class interval is 10. The size of this class interval is 10. Like this, we had to prepare a column. Understood this column, my children? Right. Now we have to find the modified lengths of the rectangles by using this formula. What is the formula? Frequency, that is length of the rectangle by width of the rectangle into the minimum class size, that is 10. yes or no, this is in these class sizes, minimum size is 10, so into 10. By using this formula, we had to modify the lengths of the rectangles of each class. Understood this point, my children? So by simplifying these two numbers, we get 3.5. Similarly, take this as second class. The class frequency is 10, that is length of the rectangle is 10 by width of the rectangle. Class is 10 into the minimum class size. Okay, my children, this point is common minimum class size. That is by simplifying these two numbers, we get 10. Understood this point, my children? Similarly, come to the third class. What is the length of the rectangle? That is what is the frequency of this class interval? 10. 10 by, okay, my children, width of the class interval, frequency of this class interval is 10 by length of the class interval is 10 into minimum class size. On the whole, the minimum class size is 10, so into 10, that is equal to 10. By simplifying these numbers, we get 10. Understood this point, my children? Likewise, we had to compute the lengths of the rectangles. Understood this point, my children? Right. Since we have calculated these lengths for an interval of 10 marks in each case, we may call these lengths as proportion of students per 10 marks interval. Okay, my children. So the correct histogram with varying with is like this figure 14.1. Here we have taken marks 0 to 10, 0 to 20, 20 to 30, 30 to 40. If you observe the width of these rectangles, different width, this is length of the rectangles. The modified rectangles are considered here. Understood this point, my children? So this is a histogram of a frequency distribution with class intervals of unequal size. Okay, my children, understood this point? Right. Now come to the next point, that is a frequency polygon. How to construct a frequency polygon? This is also another visual representation of given frequency distribution. Okay, my children, there is yet another visual way of representing quantitative data and its frequencies. This is a polygon. Okay, my children, to see what we mean, consider the histogram represented by the figure 14.3 in the textbook. See that figure 14.3. Let us join the midpoints of the upper sides of the adjacent rectangles of this histogram by means of line segments. First, we have to find out midpoints of the upper sides of adjacent rectangles of that histogram. We have to join them by line segment. Let us call these midpoints B, C, D, E, F and G. Okay, my children, we have found 6 midpoints. 6 rectangles are there. The midpoints of the upper sides of all these 6 rectangles are considered as the points B, C, D, E, F and G. Now we have to join. When joined by line segments, we obtain a figure B, C, D, E, F, G. To complete the polygon, we assume that there is a class interval with frequency 0 before 30.5 to 35.5, before the first class interval and after the last class interval. Before the first rectangle and after the last rectangle, we have to assume there is a class interval with the frequency 0 and we have to find out their midpoints. Let us assume that they are A and H respectively. Okay, my children. Now we have to join A, B, C, D, E, F, G, H. This is a frequency polygon corresponding to the data shown in the figure 14.3. We have shown this figure in the 14.6. Okay, my children, right. See here, my children, these are the limits of the class intervals: 25.5, 35.5, 35.5, 40.5, 45.5, 50.5, limits of the class intervals. Here, number of students. Here, the class intervals are started with 30.5. So here we have given a break on x-axis. Do you remember this point, mentioned? If the class intervals are not starting with 0, we had to give a gap, and here at the origin, near the origin on x-axis, we have to give a break line like this. Okay, my children, right? Now this is the histogram of the given frequency distribution. Now this is the midpoint of this rectangle, this is the midpoint of this rectangle, and D is the midpoint of this rectangle, E is the midpoint of this rectangle, F is the midpoint of this rectangle, and G is the midpoint of this rectangle. We have found midpoints of the upper sides of the adjacent sides of the rectangles. We have found midpoints of every upper sides of the rectangles. Here we have to assume that a class interval before this first rectangle. Here 30 to 35.5. So before this one we have assumed that 25.5 to 30.5 with 0 frequency. Okay, similarly after the last rectangle we have assumed a class interval 60.5 to 65.5. This is a class interval with the frequency 0. So the midpoint of this class interval is H. Here we have considered as A, the midpoint of this first class interval. So we have to join these points by line segments AB, BC, CD, DE, EF, FG, GH by dotted lines. Please remember this point, my children. We have to use dotted lines to join these midpoints of the rectangles. Understood this point, my children? With the help of histogram, we have drawn frequency polygon. This dotted line graph denotes the frequency polygon of the given frequency distribution. Okay, my children, understood this point? Right. Although there exists no class preceding the lowest class and no class succeeding the highest class, addition of the two class intervals with 0 frequency enables us to make the area of the frequency polygon the same as the area of the histogram by taking the two class intervals before the first class interval and after the last class interval. We have to assume two class intervals with 0 frequency. This enables us to get the area of the frequency polygon is equal to the area of the histogram. Okay, my children, understood this point? Right. Now frequency polygons can also be drawn independently without drawing histograms. In the previous example, we have drawn histogram first to the given data, but without drawing histograms, we can directly draw the frequency polygon for the given data. For this, we require the midpoints of the class intervals. To draw the frequency polygon without using the histogram, we had to find out the midpoints of the class intervals. These midpoints of the class intervals are called class marks. What are the midpoints of the class intervals called? Yes, class mark. So to find the class mark of a class interval, we find the sum of the upper limit and the lower limit of a class and divide it by 2. Thus, class mark is equal to formula upper limit plus lower limit by 2. So by using this formula, we have to calculate class mark of each class. Okay, my children? Right. Now let us consider an example to understand this concept well. Without using the histogram, how to construct a frequency polygon for a given frequency distribution. Okay, my children. Right. See this example. In a city, the weekly observations made in a study on the cost of living index are given in the following table. See this table, my children. Cost of living index 140 to 150, 150 to 160, 160 to 170, 170 to 180, 180 to 190, 190 to 200. These are the cost of living index. The number of weeks here 5, 10, 29, 6, 2. Okay, my children. So for this data, without constructing a histogram, we have to draw a frequency polygon. Draw a frequency polygon for the data above without constructing a histogram. Understood this point, my children? Right. Now come to the solution part. Since we want to draw a frequency polygon without a histogram, here we are not constructing the histogram of the given frequency distribution. Without constructing the histogram for the given frequency distribution, we are drawing the frequency polygon to the given data. Okay, my children. Let us find the class marks of each classes given above. That is 140 to 150, 150 to 160 and so on. So upper limit of this class is 150 and the lower limit of this class is 140. So what is the class mark? 150 plus 140. Upper limit plus lower limit by 2. Understood this step, my children? Right. That is equal to 290 by 2. By simplifying this number, we get 145. Understood this step, my children? Continuing in the same manner, we find the class marks of the other classes as well. We can find the class marks of the remaining class intervals. Okay, my dear children, understood this point? Right. Now see this table, my dear children. These are the classes. Here we have found class marks 150, 140 to 150. Class marks 145 we have already calculated. Similarly, we have to find the class mark of this class interval. 150 plus 160 by 2, 155. 160 plus 170 by 2, what will you get? 165. 170 plus 180 by 2, we get to 175. 180 plus 190 by 2, we get to 195. 190 plus 200 by 2, we get to 195. Understood all these 7 values, my children? Right. These are the frequencies. We have found class marks of each class and these are frequencies. Now without constructing a histogram, we are drawing the frequency polygon for this data. Okay, my children. We can now draw a frequency polygon by plotting the class marks along the horizontal axis. Here we have marked class limits. Okay, my children. Class marks of these classes. So 130, 135. Before this class, what will get to 135. So here we have marked only class marks, not the class limits of the class intervals. On the x-axis, remember this point, my children. Here we are not marking the limits of the class intervals, only class marks of the class intervals we have written. So 135, 145, 155, 165, 175, 185, all these numbers were marked on this x-axis. Okay, my children. On y-axis, number of weeks, frequencies. So 135 is 0 because we have taken 0. After this class also we have taken 0. Okay, my children. So this is marked as point A and this is marked as point H. Here 145 5. So 145 5. Next 155 10. By using the concept of coordinate geometry, we have to assume that this is x coordinate, this is a y coordinate, this is x coordinate and this is y coordinate. Okay, my children. So we get ordered pairs like this: 145, comma 5, 155, comma 10, 165, comma 20, 175, comma 9, 185, comma 6, and 195, comma 2. Okay, my children. So we got all these 7 points. Now we have to join all these 7 points successively. So A, B, B, C, C, D, D, E, E, F, F, G, G, H. This is the required frequency polygon for the given data. Okay, my children, understood this point, how to construct a frequency polygon for a given data without using the histogram. Okay, my children, right. Frequency polygons are used when the data is continuous and very large. It is very useful for comparing two different sets of data of the same nature. So in this case, we use the frequency polygons to compare two different sets of data of the same nature. For example, comparing the performance of two different sections of the same class. Understood this point, my children? Where we are using the frequency polygons. Okay, my children, right.